This week on the show, we explore whether BSD can replicate Cisco router performance in a good way, look at RedGuard, which is OpenBSD's new exploit mitigation technology, have a look at Dragonfly's HAMMER2 file system implementation, and we do an interview with co-op students by the FreeBSD Foundation. So there's something for everyone in this week's episode of BSD. Now. BSD Now, episode 211. It's HAMMER2 time. Recorded for the 13th of September, 2017. The day after my birthday, by the way. My name is Benedict Reuschli, I'm your co-host.
And I'm Alan Jude.
And we have a great episode prepared for you. You should really be excited about this because we have not only a great interview, but also a couple of good headlines this week. Starting off with, can a BSD system replicate the performance of a Cisco router?
This is over on Reddit in the networking subreddit. And it's a very detailed response to this question that explains a lot of stuff. We won't be able to go through all of it, so you should definitely follow the link and head out there and check a lot of that out and read through it yourself. But we'll cover some of the highlights to pique your interest. So the answer in general is, can a BSD router replace a Cisco ASR? In 3 words, no and yes. So starting with a bit of background, traditional routers were built with tightly coupled data planes and control planes. Back in the 80s and 90s, the data plane was running in software on commodity CPUs with proprietary software. As the needs and desires for more speed and more feeds grew, the data plane had to be implemented in ASICs, which are specially designed CPUs, or FPGAs, which are specially designed but programmable CPUs. And they had custom memories and TCAMs. While these are still programmable in a sense, they certainly aren't programmable by anyone but a small handful of people who develop that hardware platform. The data plane is often layered, where features not handled by the hardware plane are punted up into software and run on a more general CPU. The performance difference between the two typically are an order or two of magnitude. And they have a source where they kind of explain where all that came from. But in general, what it means is, except for when you start looking at encryption, the true measure of a router in its performance is the packets it can forward in 1 second. This is normally expressed in packets per second, or PPS. To do line rate forwarding on a 1 gigabit interface, that is to send the worst case scenario maximum number of packets, which would be the smallest possible packets, if you're sending the smallest possible packets, in order to get up to a gigabit, you would need to send 1.488 million packets every second. So to forward at line rate for 10 gigabit, you'd have to be able to forward 14.88 million packets per second. Of course, that's the smallest possible packets. In a non-worst case scenario, it wouldn't take quite as many packets per second to do a gigabit. But if you're measuring performance, it's best to do the worst case, and then that it'll be able to at least do that much. More likely, more than that. So yes, even on larger hardware, kernel forwarding, like that in FreeBSD, is limited in speed, and back in 2014, that on FreeBSD topped out at 2 million packets per second, which was, good for a gigabit, but not very good for 10 gigabits. So the poster here, who's Jim Thompson and George Neville-Neal, presented a paper at BSDcon, kind of detailing the results of their performance tests on this. However, once you export the code from the kernel and start, you can change things. There are a few open source code bases that show the potential for kernel bypass networking, basically building a software router. The first of these is netmap-forward, which is the FreeBSD IP forward code taken out of the kernel and put on netmap, which is a userland-based forwarding packet management system on FreeBSD, which is a kernel bypass technology. But it's also available on Linux. Netmap is available on both platforms. And he says, full disclosure that NetMap Forward was done at Netgate, which is the company that Jim and his wife own. NetMap Forward can do L3 forwarding, so that's IP forwarding, at around 5 million packets per second. So compared to the 2 million that FreeBSD could do at the time, that's pretty good. There's also another approach, Nanako Momoyama, sorry, she was at BSDcon just the other weekend, who's at the Keio University Tokuda lab and is working on IP forwarding FastPath, and she presented that at BSDcon in May. She was able to get about 5.6 million packets per second, or roughly 10% faster than NetMap Forward, using a similar approach of taking the FreeBSD's kernel IP forward code and making it a module for Valet, which is the NetMap-based in-kernel switch designed in FreeBSD. And the slides are available there. There's quite a bit of improvement there, because if you go back to the talk she gave at EuroBSDcon in Serbia in, I guess that would have been October 2016. Yep. At that time, that same work could only do 2.8 million packets per second. She was able to more than double the performance between October and May. And they talk about some other technologies going on there as well. But then they say, not too long after NetMap Forward was open sourced, Gandhi, the domain registrar and hosting company from France, announced their system called Packet Journey, an application based on drivers and libraries from DPDK, which is Intel's driver development kit. Packet Journey is also an L3 router, and the GitHub page for Packet Journey lists performance of about 21 gigabits per second for 64-byte UDP frames with 50 ACLs and 500,000 route entries. So with 64-byte frames, that roughly translates to 32 million packets per second. And so he says, to be blunt, Packet Journey is faster, largely because compared to efforts like NetMap Forward and the Momoyami, is that it's not the FreeBSD IP forward code. It's specifically designed, new. And then they talk a bit about how that works and how it's still a little specific to Linux. Because it uses the netlink interface to get the routes from a daemon like Quagga into the Packet Journey thing. But then finally, there's been recent work on the FreeBSD kernel, which is now available as part of FreeBSD 11.1. That more than doubles the performance of NetMap Forward. So the FreeBSD kernel in-kernel forwarding is now twice as fast as NetMap Forward. So you can actually get about 10 million packets per second from a FreeBSD kernel nowadays, just by using FreeBSD 11.1. And there's a link there to Olivier Cochard-Lebey's recipe for building a 10 million packet per second FreeBSD router. And what'll be really interesting is upcoming later this month will be Olivier actually presenting some of his even more recent work on this at EuroBSDcon. So he says, but of course, even as FreeBSD gets up to being able to do 10 gigabits at line rate, right, we're at 10 out of 14 million packets per second. And again, those are worst case packet per second. If you have a general mix of packet sizes, then 10 million packets per second is going to be more than 10 gigabits. And so you're going to run into the limitation of the interface, not of the CPU power and the routing power of the router. Especially for like my use case, which is mostly streaming video, most of the packets are full-size packets, 1,500 bytes, not 64 bytes. So that can make a big difference. But, 10 or 40, 50, and 100 gigabit interfaces are not uncommon now. And, only being able to do 10 million packets per second at 100 gigabit maybe isn't going to be enough if you're trying to route that kind of traffic. But so he goes on here. even with the fastest modern CPU, it's still very little time to do any kind of meaningful packet processing. Even at 10 gigabits, your total budget per packet to receive the packet, pull it in, copy it off the NIC into the OS and make your decisions about it, process it, and then transmit it and send it back out the other NIC, you have 67.2 nanoseconds. That's 67 billionths of a second. Complicating the task is the simple fact that main memory is 90 nanoseconds away. 70 nanoseconds away. So there's not enough time to copy it to memory and back. It all has to stay in the processor cache in order for this to work. So the simple conclusion here is that even at 10 gigabits, if you have to hit RAM, it's going to tank your performance. Then they have some really interesting talk here about the Ryzen CPU architecture and how the fact that its memory is actually further away because of the CCXs, that it might actually be worse for this type of workload. And then looks at the math of, if you're trying to do 100 gigabit, then suddenly, you have 33 compute cycles. All right, so you have to do 100 gigabit, you have to route each packet in 6.7 nanoseconds. You don't have 67 nanoseconds anymore, you have 6. So there's lots more detail in there. You should definitely check it out. It talks a bit about how the caching works and the good and bad of all that. Anyway, those are all very interesting, but the natural winner here is this new system from fd.io called Vector Packet Processing. There's a blog over at cisco.com that explains how that works. VPP is an efficient, flexible, open source data plane. It consists of a set of forwarding nodes arranged in a directed graph and a supporting framework. The framework has all the basic data structures, timers, drivers, etc., and interfaces for both DPDK and NetMap. A scheduler, which allocates the CPU time between the graph nodes, performance and debugging tools like counters and built-in packet tracing. The latter allows you to capture the paths taken by the packets within the graph with high timestamp granularity, giving you full insight into how each packet is actually transiting through the router. The net result here is that Cisco has shown the ability to route packets at up to a terabit per second using VPP on a 4-socket Purely system. So on a high-end Intel machine with 4 really big Xeon processors in it, Cisco has managed to route a terabit per second, or 10 times 100 gigabits.
Yep. With
a stock x86 machine. Now, a very expensive, very big one, but still. It shows that with the right software, you can do quite a bit. So, in the end, the answer is that up to 10 gigabits, FreeBSD is pretty good now. You can probably do everything you were going to do with the Cisco and probably for quite a bit less. But for the future, it looks like this VPP thing is the way to go. So there's also some discussion of the future of pfSense and how pfSense 3.0 will be based on this VPP forwarding system. And there's a bunch of other information. All of it has links back to sources and papers and slides from conferences and posts from Cisco and the fd.io website and lots of other stuff.
Yep. Well, worth checking out. And there's also a couple of people replying to that. And there's a good discussion going on there on Reddit.
So one person asked a question. All of that was one of the answers. There are other comments too. And we only covered about a third of the answer. There's a lot more technical detail. So if you're interested in Redding, you should definitely check it out. Even if it's just to get a slightly better understanding of how routing actually works.
Yeah, and what the BSDs have to offer, in this case, FreeBSD in the routing sector.
Yep.
Okay, next story is RedGuard, the Openbsd next level in exploit mitigation, is about to debut. So this is a posting on Openbsd-tech by Theodore Rath. And it starts with, this year I went to BSDcon in Ottawa. So this is this year's conference, 2017. I spent much of it in the hallway track and had an extended conversation with various people regarding our existing security mitigations and hopes for new ones in the future. I spoke a lot with Todd Mortimer. Apparently, I told him that I felt return-address protection was impossible, so a few weeks later, he sent a Clang diff to address that issue. The first diff is for AMD 64 and i386 only. In theory, RISC architectures can follow this approach soon. The mechanism is like a userland stack ghost in the function prologue and epilogue. The preamble XORs the return address at top of stack with the stack pointer value itself. This perturbs by introducing bits from ASLR. The function epilogue undoes the transform immediately before the read instruction. ROP attack methods are impacted because existing gadgets are transformed to consist of gadget artifact, mangle, return address, return. That pivots the return sequence of the ROP chain in a highly unpredictable and inconvenient fashion. The compiler diff handles this for all the C code, but the assembly functions have to be done by hand. I did this work first for AMD 64 and more recently for i386. I've fixed most of the functions and only a handful of complex ones remain. For those who know about polymorphism and pop, jump, or JOP, we believe once standard return is solved, those concerns become easier to address, perhaps separately in the future. In any case, a substantial reduction of gadgets is powerful. And for those worried about introducing worse polymorphism with these XOR return epilogues themselves, the nested gadgets for 64-bit and 32-bit variations are +1. There's a little section of assembly code here. Yeah, and so that's more probably easier to understand when you read the code. So over the last 2 weeks, we have received help and advice to ensure debuggers like GDB, EGDB, DDB, LLDB can still handle these transformed call frames. Also in the kernel, we discovered we must use a smaller XOR because otherwise userland addresses are generated and cannot rely on SMEP, as it is really new feature in the architecture. There were also issues with pthreads and DLSIM, which led to a series of uplifts around built-in return address and dwarf CFI. And application of this diff doesn't require anything special. A system can simply be built twice, and shorthand by building and installing gnu/user-bin/clang first, then a full build. And he writes, we are at the point where userland and base are fully working without regressions, and the remaining impacts are in a few larger ports which directly access the return address for a variety of reasons. So work needs to continue with handling the return address swizzle in those ports, and then we can move forward. And you can find the full patches listed in his posting.
Yeah, so set up patches for Clang to make it compile with these return address guards built into the applications that it compiles.
Mm-hmm. Yeah, I think we're going to see some report or some kind of presentation about this from the Openbsd folks at one of the future BSD conferences. Would be interesting to see that it works, but also what kind of attacks it protects against, and like the whole concept, how it works, and things like that.
This week's episode of BSD Now is brought to you by DigitalOcean. Head over to digitalocean.com and try it out. So you go over there and you can rent cloud server instances by the hour or by the month. And you can start as little as $5 a month. And when you sign up, if you use the coupon code Freebsd Now, they'll add an extra $10 of credit to your account so you can continue to play with FreeBSD on us. Mm-hmm. But one of the other great things about DigitalOcean is their community pages where they actually have tutorials on how to do stuff. They have quite a good mix of different types of tutorials, whether it's, how to, or what the difference is between an object store and a block store, and comparing those two services, or how to make your own webmail server with Roundcube, and lots of different things. A bunch of them are nice series that go together, and they have a good bunch of FreeBSD-based tutorials as well.
Mm-hmm. They're also great in the networking area, so you can easily add a load balancer to your little droplet, which is your machine in the DigitalOcean Cloud. They also have floating IPs, so they can redirect network traffic between any of your droplets within the same data center using a floating IP. Or you can set up a firewall relatively easy by defining the setup rules or the filtering rules that you want to have. And there's a bunch of cool networking stuff that they provide for you. And they have data centers probably in your location. So they are in San Francisco, Toronto, New York City, London, Frankfurt, and Amsterdam, as well as Bangalore and Singapore.
Yep. And I just checked on their tutorials page. They have 44 tutorials that mention FreeBSD specifically.
Oh yeah,
like
you should find something.
How to install Ruby on Rails on FreeBSD using RVM, or how to run a Django-based site in Apache and MySQL on FreeBSD.
Things you always wanted to try out.
Mm-hmm. So, in addition to providing you the server to do this on, they also have really nice tutorials, and they have a community set up where you can actually get paid to write a tutorial.
Yeah, so if you have something in mind and have this implemented and use this for a couple of instances already, then you might as well write this up for other people to use and get paid for that.
Yes, tutorials get paid $200, although certain ones that they're on topics they're really after, they will pay actually $300. And updates to existing tutorials. So a couple of those tutorials are for like FreeBSD 10 to something. Updating them pays between $50 and $100.
Yeah, so that they ensure that they're always up to date and run the latest version that you can also get on the DigitalOcean Cloud as your little droplet.
Yeah, so I mentioned this mostly because the more FreeBSD tutorials we have on there, the more people are going to try FreeBSD on DigitalOcean. And we like to have good tutorials.
Yeah, and I mean, many people discover that they pretty much can do the same things that they can do on a traditional server platform, and doesn't have to be a specific distribution maybe. So it's all easy and easily prepared for you on the DigitalOcean Cloud.
Yeah, and a lot of times you'll find that it's actually easier to do on FreeBSD than Linux because you won't have to turn a bunch of things off and twiddle a bunch of knobs first.
Mm-hmm. Or it's faster. If you are running certain applications or services, you might find that with the BSD network stack or the virtual memory system, that's totally different than on the other operating systems out there. There might be some performance improvements you might find. This week, we're joined by our FreeBSD Foundation co-op students and Ed Mast, who made the whole thing work for the first time. So welcome to the show.
Thank you.
We have a couple of questions prepared for you, as always. So first of all, is always welcome to the show, of course. And the question we always ask everyone who hasn't been on the show before, how did you first get started with Unix or the BSDs?
Well, okay, I'll let my co-op students introduce themselves briefly and take away that question.
Mm-hmm. Yeah, hi everyone, I'm Guangyuan Yang, and you can just call me Charlie. And
my name is Shiva. I'm also an intern at the FreeBSD Foundation here with Charlie. So I started with FreeBSD when I was working for a company 10, 15 years ago that had a product based on FreeBSD, and I started improving and back merging fixes and working with the community to make sure that the FreeBSD met the needs of this embedded appliance, and then just continued on working with it from there, and eventually ended up leading the operating system group at that company, and went on to do more and more work with FreeBSD, eventually joining the foundation and being elected to the FreeBSD core team. But I'll let Charlie explain his background.
Yeah, so as an undergraduate student, I don't have a lot of experience with Unix, but I do have a funny story about it. It's that during my high school, when I was introducing to computer science, and I'm getting really interested into trying out different operating systems. And of course, now I know it. I was just trying out different desktop managers. But back then, I downloaded a bunch of operating systems, including FreeBSD 8 or 9, and I installed it in the virtual machine and wait for the desktop to show. And then I realized it's actually waiting for me to enter something, and I just gave up. So back then. So that's my 3 minutes initial contact with FreeBSD. But of course, the real thing began here. So it's pretty exciting.
Right, and I have a very similar story as well. Not so much with the desktop managers, but we are still fairly young, so our experience with a true Unix is very limited, especially back when we were first toying around with Unix-like operating systems. But, when I first started learning how to program back in grade 9, I used to love Ubuntu and Debian-based distributions in Linux, and started toying around there, worked a little bit more to learn about the command line interface and the various tools that are found on most Unix-like operating systems. And then, slowly start to go into more of the advanced do-it-yourself kind of distributions like Arch Linux tends to be. And, this is actually the first probably introduction into a straight Unix operating system that I got. And, ever since, I've been trying to learn more about it at home, and same with Charlie as well.
So what was interesting in the Foundation's co-op job posting that got you interested in actually applying for this position?
I'll talk. And of course, the name FreeBSD itself is very exciting for me to apply to the Foundation. And it seems to me like a once-in-a-lifetime opportunity to do such a co-op term in an open source operating system organization. So yeah, and I get to apply my limited knowledge into this field, and I've got to learn a lot. So that's pretty exciting.
Mm-hmm. Yeah, and I think that was actually one of my first choices, when I was applying to various co-op positions. As soon as I saw the name FreeBSD, as Charlie said, it really popped out to me, specifically because of the fact that it's such a well-reputed open source project out in there. And additionally, at that point, I'd heard of a few stories of success, namely at Sony's PlayStation 4 and WhatsApp's backend servers. I read the blog post describing about how FreeBSD is such an amazing tool in their servers. And, to be involved in that project, especially right after learning exactly what an operating system is comprised of at university, it was a pretty big shock to me to see it right in my own hometown, so I really love the opportunity here.
Yeah, I guess we have to ask Ed as well to how you got the idea of doing this co-op thing.
Yeah, so I was a co-op student at the University of Waterloo when I went through for computer engineering some 20 years or so ago, and I did 6 work-term placements with companies at the time. So I had some familiarity with the co-op process through UW, and then also when I worked at another company a few years ago, we had some co-op students from the University of Waterloo working for us. So I was familiar with the program a little bit, and as the foundation's budget has grown a little bit, as donations have increased, this seemed to be a really unique and interesting opportunity for us to take on, to bring on co-op students who can give us sort of a fresh look at FreeBSD. And a lot of us who have been working in the project for a long time kind of don't see a lot of the rough edges or flaws or things because we're just sort of used to it. So I think it was excellent to be able to bring on people who are just learning and developing their operating system skill set and give an opportunity both to learn about how things are happening in a viable open source operating system project and learn from them sort of with a fresh set of eyes.
Mm. Yeah, I think you already touched on this a little bit, but to complete the question here is, what have you been studying at the university? So that was pure computer science or something related?
Yes, I'm a second-year student at the University of Waterloo studying math and computer science.
Yeah, I mean, I'm exactly the same, third-year student, and specifically more that's relevant to this. You know, while I was applying to this job, I was actually going through the operating systems kind of 101 course that we have at University of Waterloo, which is CS 350, and basically goes over the internals of a very bare-bones Unix-like operating system called OS 161. Maybe you might have heard of it from Harvard.
Yeah, and I already had my Unix 101 here. So
that's a good start, yeah.
Yeah, you'll have a good jump on the course when it comes out.
So how did this co-op term compare to maybe previous ones you've done previously? So previously, I've worked in a range of different places. This is my third co-op job, but I mean, I would really consider it my fourth, kind of, because the first job I ever had was a very similar structure. I've worked in a startup company in Waterloo at the Velocity Garage, actually, and they are focused on web development for education software. So it was a very different workflow there, and I was actually just learning how to program in a professional environment at that time. So I was very new to it. But then contrasting that to the next job I had was at a very big corporation in California. And there also I was working on cloud-based software written in Java. So I think I picked up a lot of the skills that in terms of at least doing best practices and implementing very tried and true methods to your code. I learned a lot there. But I would say that nothing really compares to the opportunity that I got here in terms of the challenge factor. The things that I learned there, I was working on at home, and a lot of my side projects were also implementing fairly similar techniques and also using different frameworks that were also in the professional environment. But, at FreeBSD, so far, I got to say that I'm very challenged by the pure technicality and the domain knowledge required to dive into the code.
Yeah, so this is my second co-op term, and I do have a previous experience in Waterloo as a software developer in the corporate office, and I've also been exposed to the DevOps sector of the company as well. But basically what I was doing was some high-level work, including web development and servers maintenance and deploy. So this is a really good chance for me to get exposed to low-level system programming. But still, I'm not already equipped with enough domain knowledge as Shiva has. As I just said, I've completed my 101 course here. But it's totally different, and it's a good difference. Compared to my previous work experience, I've got to expose to this low-level working environment, and I'll get the chance to finally work completely with the command line, and it's pretty exciting to do so.
Yeah, indeed. So have you found working for an open source project foundation versus a traditional company interesting, or what's the difference in your opinion?
I feel like we're gathered together as chatting groups online instead of sitting together in a corporate office. I don't find that really not good for our job. It's just different, and and when we actually had a chance to attend the international BSD conference, the BSDcon, at Ottawa this year, and when we meet those people that we are actually working with online, and so we really feel like we're a community, and it's really effective to work online as well. So.
Mm-hmm. Yeah, and I think one thing I might add to that is that there is a certain pleasure also in trying to interact with all these people just totally openly. You know, like the mailing lists are a good example, IRC channels that you can just join in and talk to anybody, either at the foundation or at the project. You know, it all seems actually like a much larger project than just the three of us here, right? And, you know, Ed has been really, really helpful in not only mentoring us, but also setting us with people who can kind of mentor and give advice on very specific areas of the topics that we're facing at work. You know, so it is very different, I would say, than working, like, say, at the corporate office. Like, I think this feels more like that kind of startup nature where it's very easy to talk to people, and they're very much as excited about the exact same things that you are. But you know, at the corporate office, it could be sometimes a case where you get a lot of delegation happening, right? You know, like you talk to this person, they want to talk to someone else, and they might not have time. But since everyone's working together for an open source project and a greater motive, I think that everyone's really friendly and really open to help people out, especially people like me and Charlie who are just starting, you know, and that's very nice to see.
Yeah. So you kind of touched on it previously, but with the foundation and the project being spread across so many locations and people working from home rather than in the office like you are, how did that affect how you actually got work done?
So for me, actually, I would say that most of the questions that I had, Ed was actually very keen on answering and was able to answer fully. You know, I had a couple things where I did have to reach out to people on IRC and through email as well. Specifically on the projects that both me and Ed actually had to do a little bit more research on to determine what to do next. But I would say that it's very nice. It's a very nice workflow, and simply because of the fact that everyone is working like from home or elsewhere, it didn't really stop us in any way. It didn't give us a roadblock. You know, everyone was available. At least at the foundation, they were all available on Slack all the time, and didn't have any issues getting back to us in time for what we needed.
Yeah, I guess the one thing that sometimes happens when we have a question that we need to ask someone in the community, you know, and they're not working on FreeBSD as their full-time day job, they may not be available right away, and sometimes there's some latency in waiting for a response because of time zones and people are busy and whatnot. But for the most part, I think we didn't. That wasn't even a significant factor. There were a few cases, but in general, you know, I think the FreeBSD community is very, very welcoming and helpful to and trying to you know, when people in the developer community have questions. The FreeBSD community is very good at trying to answer those questions.
Yeah, I strongly agree with that. I don't find any problems communicating with people, and Ed is really helpful with getting us started and answering basically all the questions we had. And for me, it's like using mailing lists and IRC is just as effective as the other method, and because the developers are from all over the world, so I don't see that matters to our daily job.
Well, you know, the project is pretty used to dealing with the fact that everybody's in different places. So
yeah, I mean, it's basically the way the project normally operates. There just happens to be 3 people working on FreeBSD in one office together in Kitchener at the moment. That's right.
Mm-hmm. And there's a big value in like getting people together in one room and fixing stuff you would normally not be able to in just email communication.
Yeah, and that's, I think, one of the reasons why I was really happy that we were able to bring Shiva and Charlie to BSDcon. The foundation to bring both of them to BSDcon. I think that was a great opportunity to meet people in the community and have those face-to-face discussions.
Mm-hmm.
Yeah. So now that we've picked people's interests, so what were your main objectives when you started the term?
Yeah, so this is something that I never worked before. So when I just get started, I just want to get the most of it. get used to most of the term and learn as much as I could. And I don't know what I didn't know what I will be working on before I even started. So I just want to try my best. And as I said, like in the story that in high school that I can't work with command line, in the past 4 months I set up my workflow. I configured all my environment, and that's one of the initial things that I achieved when I came here, and that's my objective, to get used to this tools in the future.
Yeah, and let me just expand on one thing there, that the way that this work term was set up, being the first time that I've gone through it with the foundation, I had a set of project ideas that I shared with Shiva and Charlie to review and sort of see where interests lie. And then, as we kind of learn how the process is going to work and how interacting with the community works and the backgrounds, we kind of prioritized different projects in there and added new ones to the list and kind of deprioritized ones that weren't going to work out. So that we over the course of the term, we really changed, I guess, and added new projects from what we had initially started thinking about.
Right. And like surprisingly, just remembering back to the time when we were actually reading through the job description, it seems that we actually hit all of the points that Ed had set for us, right? So in terms of the objectives that were set up for us, we were set to make user space library improvements or user space tool improvements, install improvements, which we could have worked on a little bit more, but maybe that would be a great project for future co-ops. And we've tested FreeBSD on a variety of platforms out there, most notably the Raspberry Pi and the Github Black. So I think a lot of the objectives that we had initially set out for, we hit pretty well. And at least more so for what I was looking for. Ed really was able to focus on exactly what I liked, which is really nice. I wanted a bit more of a deep delve into systems programming, look at the kernel a little bit more, and the projects that I were given actually reflected that pretty well. So I was very satisfied with that.
Yeah, I think it's certainly the case that FreeBSD is a pretty unique open source project for anyone who takes an interest in learning about systems programming, because it's in some ways we're small enough and approachable enough that you can come and you can meet kind of the luminaries of the BSD world. You can come to BSDcon and talk to people who were there at the very beginning and who started the whole thing off. And there's lots of opportunity to explore and work on projects of interest, and as you learn systems programming topics.
Yeah, I almost forgot that me and Shiva actually were reviewing the job descriptions once again, and we were really surprising and happy to find out that we basically hit all the objectives that Ed has set to us. And we do have a growing list of projects that we or the future interns might able to work at. And so it's pretty good that we've already hit our objectives. And
Cool. So Charlie, tell us a bit about the dashboard that you built.
Yeah, actually, we just got it ready here. So this is a dashboard of the FreeBSD continuous integration Jenkins page. We call it FreeBSD Tinderbox. Because this is like enhanced version of Shiva's work at his first day here. It's displaying the build status of the different FreeBSD different versions for different platforms. So the flashing one is currently building, and the green one is the last build was success. And it's great to see that it's all green, so it's perfect. And I've built it with BSD green, probably running FreeBSD, of course. And I've explored the GPIO and SPI functionality on BSD green and FreeBSD. And this is like a proof of concept project of FreeBSD on an ARM32 board. And so initially this was started as a side project, but now it's part of our office, and we constantly just glance at it, and we will initially know if there's something wrong that we should rush there to fix it. Yeah.
Yeah, so there's a guide on the Foundation's website that Charlie wrote that explains the whole process of building the hardware here and the software that's running on the BeagleBone Green here. And this project was partially to produce an interesting artifact that has some use, but also partially to just kind of document the steps of building something internet connected with FreeBSD. And I think it served both purposes really well. But one of the things that's really interesting is that we have it sitting in the office now. It usually just sits on top of the microwave in the office here, and it's great because we'll come back from lunch or just glance at it, and all of a sudden there'll be a red light, showing ARM64 on head is not building or is failing to build right now. And it's just sort of like you glance at it, you notice it, and then take a look and see what went wrong and see why the build failed.
Mm-hmm.
Yeah, this is
having a physical object like that is in building. Basically, you just built an IoT device. And it showed that it's not that hard to build one with FreeBSD. It's a very interesting project.
Yeah, it's definitely not. It's actually my first project here, and it's pretty exciting to do this.
Yeah. So the next question is for Shiva. Tell us about the work you did on MakeFS.
Sure. So that was actually, again, the second project that we were working on here. But essentially, so Ed had a work in progress branch for integrating a couple new features, mostly flags, from NetBSD's version of MakeFS into the FreeBSD version. Additionally, with some cleanups of the interface code with macros. So, first task to delve deep into the MakeFS and file system kernel support was to actually complete his work on those three main topics. And, after that, Ed gave me the task of implementing the MS-DOS support from NetBSD into the MakeFS for FreeBSD. That really helped me get a good understanding of the MS-DOS fat file system specification in the first place, doing research on exactly what bits need to be set where in the file system image, the format differences between 12-bit, 16-bit, 32-bit fat file systems, and many other quirks that are important to catch in order to avoid things like kernel panics or undefined behavior. So specifically, with MakeFS, this project was meant to aid in the generation of EFI boot images, because currently we are kind of doing a little bit of a hack in order to create those images. So having something in user space that doesn't require root would have been a very good thing to have. So the work right now is actually done. It's being reviewed right now and testing. I suspect that it might actually go past the end date of our co-op, but due to the fact that this is an open source project and that I'd be very interested to continue working, I'll be able to integrate fixes and improvements to anything that they say about the MS-DOS code.
Yeah, I expect that probably in the next couple of weeks it'll get merged into head. And the biggest stumbling block, I think, in the process of getting it in was we had a couple of patches. You had a couple of patches in review ready to go, and then there was some disagreement with the original approach that we took. Like NetBSD, we initially shared the same MS-DOS file system code with the kernel. So we compiled the kernel code in user space, and that's what NetBSD did as well. But there's some concern about the long-term maintainability and conflict when changes happen in the kernel and need to have updates to the corresponding userland code. So it's Chiba worked to refactor it and move all of the MS-DOS code for MakeFS into user space. And so a couple more rounds of review, I think, and it'll be in very shortly.
Mm-hmm. Cool. Can you maybe just briefly talk about some of the other projects that you've worked on?
Yeah, sure. Specifically, I think after MakeFS, we were working on implementing the EFI bootloader support for 32-bit EFI. That actually turned out to be a little bit of a miss. So it turned out that it actually took a lot more domain knowledge and knowledge about how we should fit the kernel into memory after wherever the bootloader should expect the kernel to be in memory. I did not have a very clear and thorough understanding of that entire process and the trampoline process that is required in assembly as well. So due to that, I wasn't able to continue it, but all of my work is published on my branch, so it is there for reference.
And I mean, there were a few bugs in various parts of the EFI path that you discovered during that work that have now been fixed as a result.
That's right. Yes. So it was actually a good thing to explore the code and kind of read through it line by line, just determining what they actually do, because it might have been kind of lost to time, right? A lot of people might have just continued iterating on that code. But with me specifically, this is the first time I was actually learning what the process would be like. So it was very enlightening in that respect.
So was that completely 32-bit EFI, or the special case I have with this Intel compute stick of it's 32-bit UFI, but then it runs a 64-bit OS?
So this is 32-bit EFI booting a 32-bit OS.
Right. Would it be easier to do 32-bit UFI booting a 64-bit OS? That's all I need done.
I mean, so the code is still available. We could take a look actually at providing the same handoff that we do that the 64-bit EFI provides for AMD 64 boot, and see, we can give that a try in your case and see if it works.
Sure.
Yeah, Alan is looking for that. It's clearly visible.
So I got the thing right here. So what else have you guys been working on?
Yeah.
So I guess after that, I was working on a few things related to the VT console driver. Things that weren't implemented in VT, but they were implemented in the old syscons. Things like changing the cursor shape and the cursor type, changing the scrollback buffer, having at least an interface to change it with a tool with a tool like vidcontrol, where you'd want to be able to change that scrollback history, just similar to what you had in syscons. And additionally, along the way, it also it highlighted a couple bugs with the VT console that weren't really clear. And I have a few fixes for them in review. One of the cases that are pretty interesting to discuss is if you were to go into the mount root prompt when you're booting, suddenly all of your callouts will stop working in VT. So typing any kind of regular characters, so any of the alphabet characters on your keyboard, wouldn't actually echo back to VT. But then typing a special character like Control or Shift or Alt would flush everything in the screen. So it was kind of interesting to dive deep and debug what exactly was going on. It turned out that it was a very easy kind of naive fix that I myself don't fully understand and don't have the domain knowledge to understand yet. But it is in review, and the patch is there.
Yeah, so there's a patch in review that effectively addresses the problem. In that at the mount root prompt, you can type and see the characters that you type echoed back. But there's discussion with subject matter experts going back and forth, figuring out exactly what the best fix is.
And things like this are really interesting for us as well, because it really highlights things that we wouldn't actually consider when we're just kind of naively writing code. Specifically with this case. I'm basically the fix is basically to unlock and lock a giant mutex, right? So things like this, it really shows, there are a lot more things to consider before actually trying to implement a solution to something that might seem fairly trivial at the time. And talking to all these subject matter experts, it really gives us a good understanding about what all the things we need to consider.
It's kind of an interesting way to learn operating system development in that you're, rather than greenfield writing something new, you're just trying to figure out why something didn't work and how to make it work in an existing system. Yeah,
and I mean, look, trying to figure out a problem, in something that has decades and decades of history behind it, it certainly provides a very unique opportunity.
Yeah, I see this in my university as well. We don't teach the students not to work with a large or a pre-existing code base. We just tell them write something new that's already been written 200 times before, and it's not something that they would be easy to get into. Like, there's code they haven't written themselves, they don't understand it, they need to wrap their head around it, and it's a different kind of work, but it's something they will have to do in their job later on, because there is certainly pre-existing code there.
Yeah, so I haven't had the chance to have touch with kernel, because I have to maybe studying university for a few years later, and then I'll be able to do that. But I've been working on some user-land tools of FreeBSD. One of them is the ACPI dump. I've added an option in ACPI dump as a first step of the NVDIM project that Ed is going to work on. It is to report the status of the NVDIM installed in the system. I've also been working on debugging Python tool called Diffoscope, and tried after it's being ported to FreeBSD, the test suite failed with 20 or so test cases, and I've been investigating into most of them, and most of them are because of the shared tool difference in FreeBSD and other operating systems. And I've been submitting bug reports and patches to the upstream Debian people, and now they just committed it all and solved all the problems. So the tool will be running in FreeBSD 100% with 100% test pass rate. So it's pretty good. And throughout the term, I've been trying to install FreeBSD and use FreeBSD in the Foundation's Raspberry Pi and my own 2 Raspberry Pis. I've been exploring that and report the problems along the way. So, and one of my final project will be the PiWare, porting the PiWare to FreeBSD, so that with an antenna, we will be able to report the airplane status near us to the flight aware within 200 kilometers radius. So, yeah, so it's intentionally made for the Debian-based operating systems, but I'm trying to make it work in FreeBSD. So that I will have a flying monitor running on FreeBSD, running on my Raspberry Pi.
Nice. Were there any projects that did not work out, or were there any complications you encountered?
Yes, for me, it's not really a project, but it's something that me and Shiva found out when Shiva was doing his MakeFS work, because we are constantly iterating on the project, and we are building the system, building the world probably every half an hour, and test the tools. So, and the test suite of the whole system didn't support local tests for developers back then, and it was a little bit confusing for us. So I took the initiative to try to find a better way for it to work with developers. And I actually led a small discussion in the FreeBSD developers conference summit during the BSDcon. Sadly, that didn't work out because I'll definitely need a little bit more knowledge of how the whole test suite work and how the whole system work. What I did was some like hacks, but it's good to see that someone actually took the initiative and start doing it again. And that didn't work out at first. I've been diving really deep to it, and probably I'll have a chance to work with them in the future. So that's one thing that I didn't achieve, but yeah.
Yeah.
Okay. So you said when you guys started, you didn't know very much about FreeBSD. What are some of the things you've learned? Well,
to start this off with, FreeBSD is not a Linux, right? distro. It's not a Linux distro at all. I think the fact of the matter is that it really is very helpful that the user space and the kernel space are kind of bunched into one repository, and that's one thing that I learned is a very huge advantage in the BSD world. There's a handbook out there that basically instructs you on one way of doing something that you would constantly need to do. And that one way could be, several different ways in a multitude of Linux distros with a multitude of user space tools, right? So learning the fact that, there is a great way to do something only once, there's only one way to do something on FreeBSD is very huge because you don't have to invest the time and the energy into finding very convoluted and not best practices kind of solution, right? So that is one thing that I learned a lot with FreeBSD. And I think, secondly, it's the fact that, trying to achieve a very minimal system that is kind of bare bones but does exactly what you want and does it very well is a very good mindset to have, with FreeBSD. And I learned that trying to use this operating system in the places that it would excel the most, I think that would be a very good thing to try to focus on. With a lot of these web-based projects or high-performance projects where you need the tools where FreeBSD really excels at, that's a good thing. And I learned a lot about what exactly it does excel at. So I'd be able to use this in the future with my projects and kind of tell other people about it as well.
Yeah, for me, first is to be able to answer the question like, what's the difference between BSD and Linux distros? What's the license difference? What's the design difference? I was not able to answer the questions before, but a lot of people saw me will be working on FreeBSD and they got excited and they asked me. And now I'll definitely be able to answer each of these questions. And another thing that I find is the community and a more effective way of contributing to the project. It's like if I find a bug or if I find something that it can be improved, I'll just talk to Ed and I'll probably file a bug and come up with a patch the next day and he'll get it committed to the upstream. And that's how it's done. It's not like with some other workflows in some other operating systems that might take half a year or even longer for a change to be committed. And so that's definitely one huge change that everyone can basically contribute this way very effectively.
Yeah, it's and I mean it certainly helps having working in this Kitchener office with a committer. And it's definitely a very efficient conduit to get changes into FreeBSD. But really, and that's the way that new contributors to FreeBSD work in general. If you're someone who
wants to start working on FreeBSD and submitting changes. And if you come to BSDcon and you meet a committer and work with them, and build a relationship there, that's how most of the work is coming in. People, submit a patch in Fabricator or directly to the committer they're working with. And there's pretty quick turnaround on that kind of process. And then in fairly short order after that, you go through that process a few times and then become a committer yourself. And it's a very kind of flat arrangement compared to what might happen in Linux.
Mm-hmm.
Yeah, that's something I see in other developers or committers as well. So were there any specific problems you had to overcome, and how did you solve them?
I can state one thing that also kind of something that I did learn about the project is code style is really controversial. As soon as we started working with the MakeFS code, that was an immediate dive in, right, to some both kernel level and user space level code, and it was very interesting to see, the kind of decisions I had to make and how it was regarded by the reviewers of my code. I still actually don't exactly grasp some very specifics of the Style 9 document, but
none of us do.
Right. Yeah. But that is one thing that I had to overcome. And I think it's a good learning experience to also kind of give in, right, to the overall project's opinions, right? Because I might have my own style opinions, my own ways of not only doing style, but making functional changes, right? Having some kind of paradigm in my mind before I code. But it is definitely way more beneficial, I think, to learn the ways of an open source project like this and consult other people, especially like Ed, who has been committing for quite some time. So that is one thing that I had to overcome. Additionally, I think one more thing is that I really had to lose my fear of documentation. I think that is one thing that I sort of had before, and now only that I'm realizing that, is there are so many ways to research a solution to a problem, be it man pages, handbook, obscure forums from years ago. It could be many, many different ways, right? And of course, the best documentation is to talk to the people who know about it the most. But sometimes it might seem very easy kind of just to just give into the problem and say, I want to find someone else to fix it for me, or someone else to kind of walk me through what needs to be done. One thing that I did overcome, I think, very much during this term was that I was able to be more resourceful with the things that were already published, both online and in reference books. And I'm very grateful for that, and the help that Ed gave me to do that.
Yeah, that's my take on documentation. Someone else is at this point searching for the exact same thing I'm looking for and couldn't find it. And if I found a solution or got a little bit further ahead, then I might as well document this before I forget, and also to have that other person find it.
Mm-hmm. Exactly, yeah.
Yeah, to be honest, I can't really think of any specific problems that I can explain now, but I could say it's a totally different way of doing things. So like in previous corporate office life, or in the time that I was in my spare time doing some side projects, I would just open an IDE at the left and open a Stack Overflow at the right. But what we actually do here is that there's something that no one has been solved before properly, and there's, like, as Shiva said, that's probably one of the reasons why the documentation is really important, that it's just something that is unsolved, and we might not be able to find the answer right away, and there's probably no libraries available. It's totally like exploring new fields. So it's just solving a bunch of problems ahead, I would say, every day. So yeah, so that's like not a specific problem, but huge ways of changing, changing of the ways that I do things.
Yeah, I think there's two different interesting things in what you said there. The first is that bad documentation can scare people away from reading the good documentation. That, there's no Stack Overflow on why doesn't the keyboard work correctly early in the kernel boot process.
That's definitely something we can improve, like for documentation purposes. But what all the committers are doing and what we are trying to do is more of exploring than reusing the wheels that already been created before. Yeah.
Yeah, it's the other complicated thing about documentation is that the people in the best place to write it are the people who are just getting started, and they don't feel like they know enough of it to write the documentation. And even I found myself when I first started, I started doing documentation, but as I got into more and more stuff, I found I got worse at writing documentation because there were so many steps I just did without thinking that my documentation I would write would be missing steps.
Mm-hmm. Right. So then in that case, specifically with your journey there, how did you kind of get over the intimidation factor of trying to refute something that you saw in documentation and trying to rewrite that as an early committer?
So when I started, the very first chapter of the ZFS handbook was all these kernel hacks and configuration changes you would do to make it work for i386. And I decided that should go at the end, not at the beginning. And then most of the middle was missing. So I mostly greenfield just wrote documentation that didn't exist.
Okay.
But going further than that and actually trying to get into writing source code was very intimidating at first. I'm like, well, I'm not a programmer. I'm just a sysadmin. What do I know? And so on. But
you just do it.
Yeah, there was an itch, and I scratched it, and I sent the thing, and somebody committed it. And I was like, oh, well, that wasn't so hard.
Right, yeah.
And I mean, if you have something documented, a good way is to give it to someone else and say, here, try this. Let me know if you get stuck somewhere or if there's something missing in your opinion. And then you pretty much find, if you have it in a collaborative way, that other people find the missing bits and put them together for you or tell you, hey, look at this section a little bit more or put this into more detail. And that will hopefully improve the documentation. Because if one person wrote the whole handbook, that would probably not the best document out there.
Mm-hmm.
Yeah. Exactly.
So now that your term has almost come to an end, do you think you will continue to be interested in FreeBSD and working on it in the future?
Yeah, definitely. To be honest, over the past 1 month, I've been involved in the FreeBSD Simplified Chinese documentation project. So it's definitely very beneficial to the Chinese developers, and I'll help with that a lot. Because, as you said, like people with higher knowledge tend to not write good, maintaining good documentation. And so the Simplified Chinese repository has been not very well maintained for the past few years, and I'm starting to clear things up and adding more changes to it. And I've been also trying to set up I've also been doing that, set up continuous integration systems, and I'll try to come up with a workflow that will allow the casual translator to work more effectively. And I've been setting that up. And I'll definitely work with FreeBSD in the future. I'm really willing to do that, and a perfect way is to starting from doc. And I've been in contact with a lot of doc committer, and hopefully I can be one of them in the future. And hopefully after years of study and explore, I'll be able to extend my privilege of a committer. So that's my huge plan.
I hear you.
I don't think it takes years of study, though. I didn't even go to university.
Yeah, previously it seems to me it's a place that a single person can achieve a lot, and giving back to the community and help a lot with others. So I have a lot of motivations to do that, And now I'm already getting my hands on the Simplified Chinese documentation project. And you heard my big plan. Yeah.
It's recorded now, yeah.
Yeah.
Right. Same with Charlie. This has been a very fun experience for me, I think. Having the ability to contribute back to an open source project like this is a huge plan of mine, back when I first started to learn how to program, right? So definitely I will be continuing with the FreeBSD project. Nothing really changes, after we leave the foundation. We still have our reviewer accounts, bug accounts, all those things. So it's only a matter of just staying active, seeing the commits that roll in, and checking out to see if any bugs take interest. And one thing is that, as I said before, we didn't actually get any chance to work too much on the installer and quite a bit of the user space utility improvements, I would say. So that's one thing I think would be a great project to try to hack away at, small bugs here and there. Just start to get a little bit more used to working on FreeBSD outside of work hours, doing it as a volunteer kind of role. And additionally, Ed does have a lot of good plans for future co-ops. So, working alongside with them, if there are any projects that he could also give to us, that would be pretty nice as well. One thing that he has been talking about recently was trying to integrate Lua into the installer. So that would be, an interesting thing to look at, see the progress of, and try to aid in any way. So I'd love to try to do things like that.
Yeah, we've already been familiar with the workflow, and we've been reporting bugs, and we've been taking bugs and submitting patches, and we will try to continue doing that. Yeah.
Cool.
So the question for Ed, of course, is what have you learned from this co-op experience and having students for the first time?
So I think probably the biggest learning experience for me has been in trying to properly set the scope of projects and dependencies that they might have, right? So I think that the projects that we didn't really succeed on over the term are those where I didn't really have a great handle on exactly the steps that would need to be taken to be completed successfully, and we had a lot of dependencies on people in the FreeBSD community, either helping with design ideas or kind of broader questions that we didn't have immediate answers for. So I think the key is to make sure that we have projects that are well understood and have a very clear set of steps to take on. That's probably the biggest thing from this experience. Overall, I would say that I'm extremely happy with how this work term has gone, and I'm very lucky to have had two excellent co-op students this term.
And I guess you kind of already answered the other question. So you will be continuing to do this?
So we have two new co-op students scheduled to start for the University of Waterloo winter or fall term rather, which is September through December, and then we don't have a long-term commitment in place yet, but it's a program that seems to be working out really well. So my goal would be for us to continue the foundation to continue doing it as long as we can.
Awesome.
Good.
Was there anything else that you guys wanted to talk about?
Not so much. Recently, I guess one thing that I forgot to mention that we were working on, I've been working on trying to implement the undefined behavior sanitizer support as a runtime in the kernel. That as a start-to-end project, kind of similar to MakeFS, where it had a little bit more depth to it. That was very nice. It's just finished. It's just getting reviewed right now, and it should be ready to go pretty soon. I think these kinds of projects are really, really nice for trying to inspire us to work a little bit more on not just FreeBSD, but FreeBSD-related tools, interact with third parties using FreeBSD, and open source in general. I think, as Ed said, the fact that they are continuing trying to bring in more co-ops this can only mean very good things in terms of raising awareness about the project and kind of giving good advice on how to give back to the software community like this. And it's been great.
Yeah. I just want to mention that I'll be sticking around in the future, and actually I'll be, if everything went smoothly, I'll be going to the BSD Taiwan, and hopefully I can see some of you there.
Yeah.
Oh, wow. Yeah.
All right, and I just wanted to say that for anyone who's at the University of Waterloo who happens to be watching this, keep an eye out on the co-op job postings to see if a foundation position opens up. And everyone else, please check out the FreeBSD Foundation's blog and look at the projects that we've talked about this term, and keep an eye out for projects coming up from the next 4 months of co-op effort.
Yeah, we'll be definitely following this along, and maybe we have a future interview with another group of co-op students and you. Yeah, so thank you for appearing on the show this week, and yeah, good luck to the students with your future studies. And yeah, as you said, you will probably stay with FreeBSD and the community, and yeah, we look forward to your future contributions. So after this interview, we should mention our second sponsor for this week, which is IX Systems. Go to ixsystems.com/BSD now, and you get a server buying guide from them with items you should ask other vendors whether they supply the same quality of service and customer support that IX Systems does. And you might probably find that other vendors are not that good in that area, especially when it comes to open source.
If you ask your other vendor about, ZFS, they'll be like, what's that? Or even just open source. A lot of vendors maybe claim that they have some support for it, but they really don't understand open source the way IX does, and don't have the history of being part of the community and supporting the development of open source projects.
Yeah.
So
IX Systems
definitely advertise them.
Yeah, IX Systems are really the people who are not only versed in the hardware, but also in the software. So if you mention to them, hey, I have this idea, I want to use the L2ARC or a ZIL, can you recommend me an SSD for this and this use case? And you will find that they will also tell you, well, for this use case, there's no ZIL necessary. And so they're not just telling you stuff just to sell you things, but they want to get you to do the solution properly or get the right server for the job.
Except you always have a ZIL. You can never not have a ZIL. What you're thinking of is a slog.
Yeah, a slog and like a hardware SSD.
Yes. It's called a slog. A ZIL is the technical concept, and it's always there. But anyway, yes. Well, see, they know those types of things, and they will help you. So if you call up IX Systems and explain what you want to do with the machine, they'll help you build the machine that will actually do it the best for the best price. They're really good at what they do, so you should definitely check them out. And the support doesn't end just with up till you pay them. When you buy something, they also support it after that. Great support. I had a disk die, and they replaced it really quickly. I had other problems, and they worked them all out for me very nicely. Plus, they have this great system where you can fill out this form and specify how you want the machine set up after they've physically built it. And it means that the machine can get delivered directly to the data center and just be plugged in and work, and you don't have to think about it. It's very nice. Over on their blog, they also have a great write-up here about ZFS compared with other things like ButterFS and so on. So obviously they're talking about how ZFS is better than ButterFS, and ButterFS is reaching misfortunes with Red Hat and so on. But a point they really bring up is how we don't want to end up in a monoculture where ZFS is the only thing. It'd be really helpful to have another good option, and currently there isn't one. And that kind of leads us directly into our next story.
Yep, which is also about file systems. So we have in our news roundup this week a story about Dragonfly, because they will soon release, or by the time this show comes out, already might have, a new initial HAMMER2 implementation released. So here on Dragonfly BSD's mailing lists, we have a posting by Matthew Dillon for you. And it starts with the next Dragonfly BSD release, probably in September. And so by the time this show airs, you will probably have this available. It will have an initial HAMMER2 implementation. It will be considered experimental and won't be an installer option yet, but this initial release will only have single image support operational plus basic features. It will have live DDub for copies, compression, fast recovery, snapshot, and boot support out of the gate. So this sounds similar.
Live deduplication. So when you copy a file from here to here, it actually is basically doing dedupe on it and just incrementing all the reference counts, basically, is quite an interesting feature. Hammer has the advantage of being able to design some of the features of ZFS, but design them in a different way. Or designing to the features ZFS doesn't have. I think my biggest criticism of HAMMER1 was the fact that it still expected you to rely on hardware RAID to provide any kind of redundancy and so on.
Yep. So the next paragraph here mentions that the first HAMMER2 release will not have clustering or multi-volume support, so don't expect those features to work. So they need a little bit more time to flesh those out. I may be able to get bulk DDub and basic mirroring operational by release time, but it won't be very efficient. Also right now, sync operations are fairly expensive and will stall modifying operations to some degree during the flush, and there is no reblocking yet. The allocator has 16 kilobyte granularity, which on HAMMER2 it was 2 megabytes, so for testing purposes it will still work fairly well even without reblocking. And the design is in a good place. He's quite happy with how the physical layout turned out. Allocations down to 1 kilobytes are supported, and the free map has a 16 kilobyte granularity with a linear counter, 1 counter per 512 kilobytes, for packing smaller allocations. inodes are 1 kilobyte and can directly embed 512 bytes for file data for files less than or equals 512 bytes, or have 4.
Similar to the embedded block pointer concept in ZFS.
Or they can have 4 top-level block refs for files greater than 512 bytes. The free map is also zoned by type for I/O locality. These block refs are fat at 128 bytes, like that, but enormously powerful. That will allow us to ultimately support up to 512-bit crypto hash and blind DDub using said hash. But on release, that's the plan. So there are some things not in the release, but they have some things planned for the future, and those look actually quite interesting. So he writes, I came up with an excellent solution for directory entries. The first 1 kilobyte or the 1 kilobyte allocation granularity was a bit high, but it didn't want to reduce it. However, because block refs are now 128-byte entities and directory entries are hashed like in HAMMER1, I was able to code them such that the directory entry is embedded in the block ref itself and does not require a separate data reference on allocation beyond that. File names up to 64 bytes long can be accommodated in the block ref using the check code area of the block ref, and longer file names will use an additional data referencing hanging off the block ref to accommodate up to 255 character file names. Of course, a minimum of 1 kilobyte will have to be allocated in that case, but file names are less than or equal 64 bytes in the vast majority of use cases, so it just isn't an issue. And this gives directory entries optimal packing and indexing and is a huge win in terms of performance, since block refs are arrayed in 16 kilobytes and 64 kilobyte blocks. In addition, since inodes can embed up to 4 block refs, the directory entries for small directories with less than or equal 4 entries, like dot and dot dot, they don't count, can actually be embedded in the directory inode itself. So generally speaking, he finishes that mail, the physical layout is in a very happy place. The basics are solid on my test boxes, so it's now a matter of implementing as many of those and more sophisticated features as I can before release, and continuing to work on the rest after the release.
So
exciting.
It's interesting to see HAMMER2 actually coming to the point where it can be used.
And I guess there will be also a couple of benchmarks coming in the future. But with some of those features are yet not implemented. You cannot expect the full feature set and being available. So they need a couple of iterations to tune these, I guess. But it's certainly interesting to see those features in action and having users try it out.
Yep. So our next story is from Openssl about removing some code, but not OpenBSD style. Their methods are a little different.
Unfortunately, yeah.
This is another update in our effort to relicense the Openssl software. Our previous post back in March was about the launch of our effort to reach all the previous contributors in hopes that they would support this change. So far, about 40% of the people have responded for a project as old as Openssl, including its predecessor SSLEA, which is 20 years. That's not too bad. We'll be continuing our effort over the next couple of months to contact everyone. For those people responding, the vast majority have been in favor of license change. Less than a dozen have objected. This post describes what we're doing and how we came to our conclusions. The goal is to be very transparent and open with our processes. First, we want to mention that we respect the decision of those people who rejected the option to relicense. While it is inconvenient for Openssl, we acknowledge their right to keep their code under the terms that they originally agreed to. We have asked permission to change the license terms, and it's fully within their right to say no. The license website that they've set up is driven by scripts that are freely available in the license section of the tools repositories on GitHub. When we started, we imported every single Git commit looking for anything that resembled an email address and created tables for each commit, each user we found, and a log that connected users to the commit. This did find some false positives. Sometimes email message IDs showed up as email addresses, and they were very often mention of folks as a passing side comment or something, or because they were in the context of a diff. The user table also has columns to record approvals or rejections of the license change and any comments that they left. Most of the comments have been supportive, and a bit surprisingly, there's only been one or two that have been obscene. They've created a new script called What to Remove that finds any user who has refused to accept the relicensing and any commits that they were named in. They then examined each commit. So far there are 86, and filtered out those that were cherry picks of other releases and so on. We were planning on only changing the license for the master branch, so the older ones don't matter. So in the other release branches, that wasn't applicable. There also were some false positives. In the end, they were down to 43 commits that required manual intervention. They said, we then reread every single commit, looking for what we could safely ignore as not relevant, and we found the following. 9 of the 40 some odd there showed up only because the person was mentioned in a comment, not because they were the person that wrote the code. 16 of them were changes to the OpenBSD configuration data. The Openssl team has completely rewritten this, refactoring all of the BSD configuration into a common hierarchy, and the config stuff changed a great deal in 1.1.0 anyway. So most of the OpenBSD specific code has been replaced anyway. 7 of them were not copyrightable because they were minimal changes, like fixing a typo in a comment. And 1 of them was a false positive. That left them with 10 commits. 2 of them were to the CryptoDev engine. They're in the process of removing that engine, as you can see in this PR, and they expect to have a replacement that will work for Linux and FreeBSD relatively soon. And so that code that can't be relicensed can just be removed. As for the other commits, we're removing that code, as you can see in this PR and this other one. Fortunately, none of them are particularly complex. Copyright, however, is a complex thing. At times, it makes debugging look simple. If there is only one way to write something, then that content isn't copyrightable. If the work is very small, such as a one-line patch, then that isn't really copyrightable. We aren't lawyers, and we have no wish to become such, but these viewpoints are valid. However, it's not technically legal advice. So they're having to be very careful about, well, when they rip this code out, that when they replace it, it's actually new code and that it's been replaced properly. For the next step, we're hoping that we'll be able to put back the code that we've removed, or rather put back different code that replaces it. We're looking for the community for help and encourage you to create appropriate GitHub pull requests. We ask the community to look at the second PR and provide any fixes. And finally, we ask everyone to look at the list of authors. And if you see your name or the name of someone you know, get in touch with them so that they can get more than 40% of the people on the list contacted.
Yep. So this is something that projects face from time to time to clean up their existing licenses or what kind of author licenses they were granted by the author that they got sent by patches or something. But this is a good overview of what kind of tools you could write to get those information out of your source tree.
Yeah, but it also shows some of the problems with just like trying to find anything that looks like an email address in the commit logs.
Yeah.
Or just the general problem with email addresses is that they very quickly rot, and it's like, oh, there are some people I know who've had the same email address for, 25 years. And there are some people I know who, if you email them an email address from last year, it's not going to work anymore.
Yeah, there's no forwarding, and it's messy, definitely.
Yeah. Especially a lot of BSD code maybe has an email address at the company where the person worked at the time, and they don't work there anymore.
Yeah, then, no forwarding address, Anyway, it's good to see that there's progress in that area. Our next story is that Theo de Rad moves us to 6.2 beta, and if you hear that, then you're probably thinking, OpenBSD, and you're right. But first of all, we also see when we click on that link in the show notes that the Undeadly org webpage that we've been covering for a while is now completely new, and they have a nice new layout, and it's much more clean in my eyes, and I think it's much more easier to grasp the actual news. So nice redesign of Undeadly. But this one mentions that the Theo de Rad, of course, has just committed the diff that marks the end of the development cycle and the beginning of the testing phase for the upcoming 6.2 release. And you can see the actual commit message there. And it's pretty much a couple of files modified that have version information in there and some other things that make a release going to happen. So 6.2 beta, you all know that what this means. Get to testing. Find whatever hardware you have and install the latest snapshots. Stress the upgrade procedure, play your favorite games, build your own code, whatever you use OpenBSD for. Try it in the new snaps and report any problems you find. Your testing efforts will help make sure 6.2 is another great release. Yeah, and since the OpenBSD folks are actually delivering their releases when they say they do, without delay and on time and on date, you can pretty much expect this release to be coming out. And of course, we'll cover this when it comes out in a future BSD Now episode.
Yeah, FreeBSD is getting better at it. Our last release was on date. We're not always months behind.
Yeah, it's depending on how many issues are discovered and what's going to be actually in the release. So it's time for our BSD news and BSD bits this week, starting with 64 hijacked ARMs. So what's this all about?
This is a follow-up to our recent coverage on libhijack. They've released version 0.8.0, which breaks both API and ABI from the previous release, but adds support for ARM64, providing its first port to a non-x86 architecture.
Mm-hmm.
So if you're interested in that, go check it out.
Yep,
then we have some more OpenBSD news.
Yep. Starting with, or the title is Smartisan makes another Iridium donation to the OpenBSD Foundation, which is great because there's money involved. The statement here by Ken Westerbeck reads, the OpenBSD Foundation is excited to announce that it has received the first 2017 Iridium level donation. For the second consecutive year, Smartisan, which is at smartisan.com, has made a donation of over 100,000 Canadian dollars to support OpenBSD and related projects. We thank Smartisan for its very generous support, and this donation will no doubt fund many exciting projects in the next few years. Yeah, this is great news, seeing that companies that are obviously using OpenBSD in one way or the other. Are they?
No, they're a smartphone company, and they just had they have a conference, and they donate the proceeds from the conference to an open source project that they select.
That's why. Okay. Well, this is also another good use of money, and money well spent, because the OpenBSD guys can use it to fund many developments, as they said, and like hackathons where a lot of bugs get fixed and new features developed. So next up is a little less happy news. So we got the news that longtime FreeBSD core team member and developer Andrei A. Chernov has passed away. So we have a link to a Twitter blog post, but we got this through other channels closer to Russia, and we could then verify this as true story. And it's sad to hear this, because a long-time developer and as also core team member, you are really involved in the project and get to know a lot of internal things and don't just contribute code here and there. So it's always sad to hear stories like this.
Yeah, and was kind of a pioneer of a lot of internet-based stuff in Russia as well.
Mm.
And the OpenBSD community has lost a person as well. Mickey Soleyev passed away as well. So there was some memorial thing at the recent hackathon they had in Toronto.
Mm.
On to other news. When you're watching this will be a bit old news, and it'll be a bit further along, but the first beta for FreeBSD 10.4 has been released. I imagine by the time you watch this, we'll be on beta 2 or 3, so that just means you're behind schedule on testing. Why weren't you testing already?
Yeah. I mean, people are asking, why are you still doing a new release of the 10 branch? But it's worthwhile to have.
In general, upgrading on FreeBSD is actually pretty easy, but when you do minor upgrades like 10.3 to 10.4, you don't have to change anything. Any binaries you have, like even if you have proprietary drivers or modules or code that's compiled for FreeBSD 10, it'll just keep working on 10.4. So it basically just allows those people that are using machines based on 10 or built appliances based on 10 to continue to a lot of fixes have gone into the 10 stable branch after the 10.3 release. Mm. And by doing this release without having to extend the support lifecycle, it means, the work we were going to do to keep 10.3 alive until the end of its life, we're going to do anyway, because we have to. So we might as well at least give you some of the fixes and all the feature improvements we've made to 10.4 in the meantime, or into stable 10 in the meantime, so that, you can do the minor upgrade from 10.3 to 10.4, and while we're still providing the support for it, you can get an even better working system.
Yep. So MFCs are there for a reason, and bug fixes need to happen in all branches.
Yeah, a lot of people using 10.3 reported problems, and they've been fixed. So wouldn't you like to have those fixes? As we get towards the new release model that 11 is on, where as FreeBSD 11.1 came out in July, 11.0 will end of life. It means that we'll be able to do roll-up releases at the end of branches a lot easier. So we kind of weaseled our way into doing it for 10.4, but going forward, it'll be much easier to do because it won't have the same level of maintenance burden.
Mm-hmm. Yep. So check that out. And our next story is VMADM in action, from getting a data set to running a jail with VNet networking in just a few commands. And this is a recording on Ascii Cinema. So this is the Ascii Cinema, where you can basically record your shell session and play back it for other people. And so what does this do? It's pretty much a management interface like VMADM list and create and stuff. And that will set up your little, it's a jail with VNet networking. So you have a separate networking stack in your jail, different from the one in the host system. And apparently this makes it really easy to set this up. It's worth checking out, I guess.
Mm-hmm.
We'll have to play with it some more.
Yeah, it looks like a very nicely put together tool, so give it a check out. And lastly, we have an interview with Patrick Witt from the BitRig project originally, I think, on the Garbage podcast, garbage.fm, which interestingly was started by someone after we interviewed them on BSD Now. They got the podcasting bug, I think.
See? Yeah, this is nice, and we have... it's good to interview people in audio, not just in text form, about their experiences at Openbsd hackathons. And give it a listen.
Yep.
And
this week's feedback and question segment is brought to you by Tarsnap. Head over to tarsnap.com/bsdnow and sign up. Again, it only costs $5.
Yeah. It's well thought out, and because it's not just a backup solution, it's the online backup for the truly paranoid. You are the only person holding the key to the decryption. So no one else will be able to decrypt this in the cloud or anywhere else, as long as you hold the key in your hands and keeps it private. And Tarsnap makes it actually quite easy to do the whole backup and restore purpose. And there's a lot of ports available for other systems like the Linuxes, the BSDs, macOS 10, the Windows subsystem for Linux as well is supported. And Tarsnap is really easy if you know how to use tar, the tar utility.
It looks just like a command to do tar, except for instead of, filename.tar, you end up with that name being the name of the backup that goes off into the cloud. It really is that easy. And they have a nice GUI now if you want to use that. So,
so there's no...
if you're a command line jockey or a GUI wizard, either way, ready to go.
Yeah, you find all kinds of ways to interact with Tarsnap and make it do the backup for you, or restore if you have a need for it.
Yep. When you have a need for it.
Hopefully not, yeah.
So actually, our first bit of feedback is actually about Tarsnap.
Yeah, so this is Seth, and he's writing us. Starts with, "Hi, Benedict and Alan. I've been listening to the podcast for about a year or so, and I've heard you mention Tarsnap on multiple occasions. Oh, yeah. I've been with CrashPlan until recently, but they decided to pull the plug on the home tier of their backup service. Well, now that I have some pain to endure to switch to someone else, I figured I might as well check out Tarsnap. I was suspicious that the syntax was close to BSD tar, but I believe it now. I got it installed and configured from my FreeNAS box, even made a nice script that emails me status reports at the end of the backup. What more do I need? All I wanted before was a no-frills backup, and at least Tarsnap does not rely on bloated Java to make things run. That's one Beehive virtual machine I can kill now. Thanks a million for promoting this great product. Regards, Seth."
Yeah, the biggest thing to watch out for when looking at other backup companies is if they're offering you unlimited storage for a small price. That doesn't work, because eventually the amount of storage you're going to use is going to cost more than the amount of money you're giving them.
Yeah.
And that's why Tarsnap charges you a price per gigabyte, because their costs are based on the amount of data you store and the amount of space you take up. So if they don't do that, then they're cheating or lying or something.
Yeah.
And if we've seen how many companies that offer unlimited storage, eventually either they have to kick the big users off because they're costing too much money, or they silently throttle you or whatever, or they go out of business or raise the price.
Because they didn't think this through or couldn't finance themselves with adding more storage. Because you can always back up one more file, one more big file, one more archive, and eventually it costs them more than it's worth for you.
Yep. So our next question is from Johnny about the memcompare article we talked about. He says, "I love the show and I'm a big fan. I enjoyed the article about the mem CMP. I must point out that it would be much better when working with character type data. It would be better to use stir n CMP and proper lengths than to use byte-level memory comparison functions. Stir NCP looks for null bytes, though, where memcmp doesn't. But I guess stir and CMP, they're about the same, I guess, yeah. A to the string BC with a length of 3. That's a contrived example in the thing. They were comparing variables, not constant strings. And what they did in the article was substitute what the values of those were in the contrived example to make it easier for you to understand what was happening. I think the strings they were looking at were actually much bigger than just 3 as a length, and so on. So it was a slightly contrived example to explain the concept without having to look at the fact that, well, they were comparing a 1024 byte string to a 1000 byte string. He says, I do thank the author of the article to point out that the undefined behavior, but I don't think it's a bug, since reasonable C programmers probably wouldn't write code like this, except for they did. That's why he wrote the article. Most people assumed that it was going to compare, when it sees the first character is different, that it was going to stop. But, glibc compares whole chunks at a time, and so resulted in this out-of-bound reads that was unexpected.
Okay. Yeah, good to know, or having this comparison with the article. Next up is Thomas with drives and NAS. So he writes, hello, first I want to say I really enjoy your show. Thank you. I'm a Linux guy, but I really enjoy hearing about everything going on in the BSD world. That's fine. I have a question regarding using ZFS in a NAS. I currently have a $S thing. Oh, okay. Yeah, here it goes. I ask this because I have a 3 terabyte Western Digital Red in my current NAS that I would like to reuse, and I have less than 4 terabyte of data. If not, I'm sure I can find some stuff to get rid of. Another question. What type of drives do you recommend for use in a home NAS? Should I invest the extra money in NAS-rated drives, Western Digital Reds or Seagate Iron Wolves, or would cheaper desktop-rated drives work just as well?
So the differences in NAS-rated drives are usually they have more anti-vibration stuff to deal with, putting 8 disks or something in one machine, and they usually have firmware that has different error recovery things. When there's an error on the disk, a NAS drive will give an error to the disk controller up, and then that'll get to ZFS, whereas the desktop drives generally try to solve the error themselves because they're afraid if they give an error to Windows, it will freak out and crash. And so there's trade-offs both ways. NAS drives are always better, but, sometimes you can't afford the extra money. Your first question is a bit confusing. So you have a 3 terabyte Western Digital Red drive in your current NAS and would like to reuse it.
Reuse that? Yeah, maybe that got cut off somewhere, or we didn't paste that.
Yeah, there do seem to be 2 places where there's just a $sign and the sentence ends unexpectedly.
So regarding the second question...
So the question is, it seems they're building a new NAS and want to copy the data from the old one to the new one, I guess?
Yeah.
Yeah, you can do that. I'm sorry, the question seems to have gotten mangled.
Yeah. Let me ask about the second question. So there is a claim by some of these NAS-grade hard drives that they are better suited for 24/7 operations, whereas desktop drives are being shut down. And
the desktop drives are designed for like a 9 to 5 office hours duty cycle, and sometimes they won't honor the warranty if they've been powered on 24/7 for a long time. Right, like the warranty is X hours of power on time, and if you go through all of that, the 9 to 5 time in 1 year on a 2 or 3 year warranty, then they'll be like, sorry, you've used up all the lifetime of that drive. And so the NAS drives have the warranty that's good for that. In the desktop, it's usually less that, but if you have to return a large volume of drives because you've been using a lot of file servers or something, they will eventually deny that and be like, you should be using the NAS drives if you are going to be using a lot of them. Often it's pretty much the same hardware, just with different firmware, but that can make a big difference.
Yeah. Yeah, I hope we could at least partially answer the question. If not, then just send us another one at feedback@bsdnow.tv. We continue with Ben's question about NVIDIA, or it's at least a little shout out here. He writes, "Hi guys, I'm not sure exactly what changed caused this actual improvement, but I have noticed that on my FreeBSD 12 current workstation, I can now toggle from X11 back to console with the VT driver. It is very nice to have my consoles back again." And he suspects that this was linked to the recent NVIDIA drivers update, and he has links to that one.
I thought that had been working for a while. Maybe not. I don't remember. But
there were some changes recently.
That's the important thing.
Yeah, there were some VT changes, some bug fixes, or some smaller improvements.
I know, Shiva worked on some of them.
See, this is a nice connection to our interview. Yeah, if more people have that experience, which is good, then by all means mention that. Because sometimes, you have the need to switch from your X11 to a real console and back again. And it used to work before we had VT, but now more and more people report that it's going to work. Okay, nice feedback here. And last for this week is David with a ZFS performance variation over NFS question. And he writes, "Hi Alan and Benedict. I'm new to the world of ZFS and have been experimenting with ZFS and have found that NFS and rsync is extremely slow, taking 5 minutes to copy 300 megabytes over a gigabit link. Looking at the FreeBSD documentation, it advises setting sync equals disabled on the pool dataset. This makes the rsync finish in 30 seconds, writing to a new directory so that it is sending all the files again and not skipping over that already exist on the destination. Is utilizing this parameter dangerous if both the server, networking, and workstation is on UPS or UPSs in case of a power outage? Is there something that I'm missing?"
So in general, you wouldn't want to set that sync equals disabled on the entire pool. You would set it on maybe one data set. But in general, you don't want to do that. So as far as dangerous, not so much. It just means that the data that's currently being written, if the system crashes or the power goes out or whatever happens, might not actually end up getting written. So rsync will have finished and you'll think all the data is copied, but if power goes out 2 seconds later, you might have lost some of the files that hadn't finished writing yet. Because when you set sync equals disabled, ZFS is buffering up the changes in memory and then writing them out later. In general, if you're using rsync, why are you also using NFS? If you rsync by connecting through rsync or over SSH or whatever, you'll probably get better performance than doing rsync over top of NFS. You say it's 300 megabytes of data, but especially for rsync, it matters more how many different files that is. The biggest thing, so most NFS mounts are synchronous, and so if you have a slog, an SSD that's doing the caching, it can also make a big difference for NFS performance. So basically, when rsync is writing stuff, when it closes a file, it won't wait until if sync is disabled, ZFS will say it's done writing the data even when it's not. And rsync waits for that. So when sync is the standard setting, rsync will pause after each file and wait until ZFS says, okay, I got that file. It's completely on disk. It'll be there if the power goes out. And maybe you don't want that. But if you add a slog, an SSD, you don't need a very big one. Like 16 gigabytes is lots. It will write the data that's waiting. The data that normally rsync would wait until it was done writing before continuing will go to the SSD, which will be able to finish writing it sooner. Let rsync continue, and then buffer it out later. The big advantage of doing that there instead of in RAM is that it will still be there if the system crashes or the power goes out.
Yep. I just looked up.
So in general, you probably don't want this on everywhere, but if there's one specific data set that you're doing this frequently, you could cheat and do that.
Yeah.
The danger is only that files that you were copying might not actually be finished copying. Right? When sync is disabled, rsync is finished and you think it's all safe to shut the machine off or whatever, but it's not quite yet.
Yeah, I have it here in the ZFS man page. So if you look up sync and the disabled column there, or in the disabled section here, it says disabled synchronous requests. File system transactions are only committed to stable storage periodically. This option will give you the highest performance. However, it is very dangerous as ZFS would be ignoring the synchronous transaction demands of applications such as databases or NFS, like in your case. And administrators should only use this option when the risks are understood.
Yeah, so in particular, what you could do instead is when you're doing the NFS mount, is make the mount asynchronous. So that NFS will not ask ZFS to, hey, wait and tell me once this file's all the way written. And it will allow you to not disable it in ZFS, but just have NFS stop asking ZFS to wait after each file. Yeah, and in general, you won't see this same kind of problem if you were copying one 300 megabyte file, because it would just be streamed and then you would sync at the very end saying, all right, now tell me when all of that data is written. So there would just be a delay at the very end while you waited for ZFS to finish flushing it out to disk. But in general, the length of the danger is relatively short. It will be, by default, the most amount of data it will buffer in memory is a couple of gigs, and however long it will take your disk to write that out.
Yeah. So
so usually, almost always, probably definitely less than 30 seconds worth of data is at risk. But, depending on your workload, that could be a big deal. If it's just backups you're copying with rsync, it's probably not. But you don't want to be cavalier about it, right? The whole point of ZFS is that it's not going to lose your files. You don't want to, turn all that off and suddenly it's not really ZFS anymore.
Yeah, not the intention why ZFS was created.
But yes, so probably your best bet is to change your NFS mount to be asynchronous, and then it should solve most of your problems. But in general, with what you're doing with over rsync, you probably want to consider not doing rsync over NFS and just use the native rsync protocol instead. Or, rsync over SSH.
Yeah, there are a couple of options.
Yep.
All right. That's been it for the week. We have a great show for you, and hopefully you liked what we gave you this week, and see you next time.
See you next time.